Hello, dear friend. This is Himmet again. Now, in this lecture, we deal with the length of a given curve. Now, suppose that the graph of the a given curve is like this, and then the length of the curve y is equal to f of x between the lines x is a and x is b is defined by this equation, which is L is equal to integral from a to b square root of 1 plus y dash square and times dx. Okay. Now, y dash means here the derivative of the given function or curve. Right. Now, to explain how can we calculate the length of a given curve, we have actually in this lecture two examples. First one is we are trying to find the length of the circle with radius r. Okay. Now, firstly, I think we need the graph of the circle. The graph of the circle is like this. Here is r, here is minus r, and we know the formula of the circle, that x square plus y square is equal to r square. And so if we look at the arc length formula, we need the derivative of the given function, and so by using this equation we can write y is equal to square root of r square minus x square. Okay, right. I am using just here. Right. Now the derivative of the given curve is y dash is this derivative of square means that derivative of inside minus 2x over 2 times itself. Right. Now we need here y dash square is, firstly we can delete minus 2 and 2, and so we have y dash square is x square over r square minus x square, and so 1 plus y dash square is equal to 1 plus x square over r square minus x square. Then this is equal to r square over r square minus x square. Right. Now, let's write the arc length formula of a curve. The length is, if we look at carefully the graph of this circle, and then here is origin x, we can calculate the length as integral x is 0 to r, okay, from 0 to r, square root of 1 plus y dash square dx. But if we look at here, we have 4 times from this length, and so let's write here 4 times this length give us the length of the circle with radius r. Okay, right, for integral from 0 to r. If we write inside of the square root of by using this equality, r square over r square minus x square dx. All right, we know that r is a length, and so r is positive, and then for r integral from 0 to r dx over r square minus x square. As you can see that here a square minus x square, we can use the substitution. X is r times sine of x, and then dx is r times cosine x. Now, if we use this, I think we put here t instead of x. Okay, let's put t instead of x. Right. If we use this new variable, we have to change integration limits, and so 0 to r, and then if this is our x variable, in our x variable appears in this interval, and then if we put x is 0, then sine t is 0, and so t is 0. If we put x is r, and then sine t is 1, which means that t is pi over 2. This is our new integration limits. in terms of our new variable t. Okay, let's write 4r times integral from 0 to pi over 2. What is dx? Dx is r times cosine t dt over r square minus r square sine square of t. If we manipulate inside of the square root, and then I think we can write here r times absolute value of cosine of t. Now, as you can see that we have absolute value here, and then to check inside of the absolute value, then we need unit circle. This is our unit circle. This side is cosine axis, and then here is 0, here is pi over 2. The cosine is, as you can see that our cosine is positive between 0 and pi over 2, and so inside of the absolute value is positive, and then I think we can write our integral for r integral from 0 to pi over 2 r times cosine t dt over r times cosine of t. Please delete similar terms, and then we have for r integral from 0 to pi over 2 dt, and then I think we can write for r t from 0 to pi over 2, and then for r pi over 2 minus 0, and then please, if you look at this expression, and then we can have 2 pi r units. Okay, and then so our result is 2 pi r is the length of the circle with radius r. Okay, now our second example is that please find the length of the accelerate x to the 2 over 3 plus y to the 2 over 3 is equal to a to the 2 over 3. Right. Now let's look at this second example. All right. Solution. think we need firstly the graph of the asteroid, and then the graph of the asteroid is right here is A, here is minus A, here is again minus A, and here is A, right? Our the formula of the asteroid is x to the 2 over 3 plus y to the 2 over 3 is a to the 2 over 3. As you can see that this is closed function f of x and y, and so the derivative of the closed function is given by f dash in terms of x and f dash derivative of the function f in terms of y, and then I am writing like this. Why? Because our formula is the length formula of a given curve L is, let's consider just this part. This part is between 0 and the length 0 and a, and so the integral from 0 to a square root of 1 plus y dash square dx. Okay, as you can see that we have such a length 4 times 1, 2, 3, 4, and so 4 times this integral, right? I am considering this derivative because we need such a derivative inside of the square root. That's why I am taking the derivative of the given closed function. Okay, minus, please take the derivative in terms of the value x, and so 2 over 3 times x to the minus 1 over 3, and so please take the derivative of the closed function in terms of the variable y, and so 2 over 3 times y to the minus 1 over 3. Please cancel similar terms, and then I think we can write, please take this term denominator as denominator y to the 1 over 3 and x to the 1 over 3, and so we need y dash square. What is y dash square? Y dash square is y to the 2 over 3 over x to the 2 over 3, and so we need one more step. 1 plus y dash square is 1 plus y to the 2 over 3 over x to the 2 over 3. Then we have x to the 2 over 3 plus y to the 2 over 3 over x to the 2 over 3. As you can see that this is actually equal to, from this equation we have seen that this is equal to a to the 2 over 3. Okay, let's write a 2 over 3 over x to the 2 over 3. Right. Now we have obtained the inside of the square root of. Let's write now 4 times integral from 0 to a, and then square root of a to the 2 over 3 over x to the 2 over 3 dx. All right. If you look at here, inside of the square root, and then this term can be written 1 over, a over 3 over x to the 1 over 3 and square. And then please cancel square root of and square, and so 4 times integral from 0 to a to the 1 over 3, and then x 1 over 3 dx. And then as you can see that this is a constant, and then we can take outside of the integral 4 times a to the 1 over 3 integral from 0 to a, and this term can be written as x to the minus 1 over 3 dx. And so I think we can write 4 times a to the 1 over 3. Our integral is x to, this is, as you can see, this is a polynomial, and so x to the 2 over 3 over 2 over 3 from 0 to a, and then let's write 4 times a over 1 over 3 times 3 over 2, and then a to the 2 over 3 minus 0. And so please cancel 2 by 4, and then 2 times 3 is 6, and 6 times a over a to the 1 over 3 times a to the 2 over 3, and so if you calculate, then you will have 8 times a unit. That's all. Thank you. Now arkadaşlar, şimdi ufak bir uyarı yapmak istiyorum. Üniversitenin web sayfasında ikinci dönem yani bahar dönemi derslerinin uzaktan eğitimle yapılacağı söyleniyor. Bunun anlamı dersler artık sınıfta yapılamayacak. Dolayısıyla bu anlattığımız konulardan yani videolarda anlattığımız konulardan vizelerde ve finallerde soru soracağız. Verdiğimiz ödevlerden soru soracağız arkadaşlar. Lütfen bu konuları ciddiye alın, çalışın, ödevleri yapın. Dolayısıyla ödevlere de bir süre tanımak zorundayız arkadaşlar. Ödevleri de vaktinde yapabilmeniz için bu YouTube'daki YouTube'a yüklediğimiz videolardan kısa sürede bildirim almak için bu işte kanala da bizim açmak zorunda kaldığımız kanala da abone olun. Teşekkür ederim.